Okay, there's your objective. Pretty simple, I think. So let's move straight into the examples. Here's section 12.3. All right, our first example states it states that we have a die with a regular die with 6 sides, and then it gives us 3 questions. I'm listing them A, B, and C. What's the probability of rolling a 4 on a die? So what you have to understand about probability is that it's always all possible outcomes is the denominator, and then the probability of our outcome is the numerator. Now, how many? So it's a 6-sided die, so there's 6 possible events. Probability of our event is just there's only one side with a 4 on it. So my answer is 1/6. Now again, if I'm rolling the second question, again I'm going to have all these questions. I have 6 possibilities. How many of the 6 sides have odd numbers on them? And again, the sides of the die are 1, 2, 3, 4, 5, and 6. So these ones are odd. So it's 3 of those. So 3/6 equals 1/2, and really 1/2 is my answer. And a number less than 7, well, they're all less than 7, so 6 out of 6 equals 1. The biggest probability I can have is 1, 100% chance of it happening. The smallest probability I can have is 0. The probability of a number greater than 7 is 0 out of 6 equals 0. So all my probabilities are between 0 and 1, pretty much. Okay? Example 2 is that I have a CD with 8 songs on it, and I set the player to play the songs at random with no repeats. So so it says, what is the probability that the songs are played in one particular order, the order that they're listed, 1, 2, 3, 4, 5, 6, 7, 8. Now, it plays them in random order, so the question we need to know is, what's the denominator here? How many possible orders are there? Well, when I'm coming up with this deal, now I'm going to use what I learned in the first 2 sections on permutations. How many orderings are there of any 8 things? And, well, shoot, 8 factorial, right? 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That's how many. So 8 factorial is my denominator, and this is just one of those orderings. So my probability here is 1 over 8 factorial, which equals 1 over 40,320. Okay, the second question on this problem asks, given you have 4 favorite songs, what is the probability that 2 of them get played 1, 2? Now so what you've got to get used to is seeing probability as a fraction with total possibilities on the bottom and a lesser number of possibilities that we're trying to find the chance of on the top. You know, with a die, it's 6 on the bottom and 1 on top. But here we've got 4. We're playing 2 songs, 1, 2. So how many possible chances are there, or how many possible combinations are there? Basically, that's P82 on the bottom, right? There's 8 possibilities for the first song and 7 possibilities left over for the second song. So there's 56 total song possibilities. Now you have 4 favorites. Put aside for the moment that that's out of 8 total songs. We're not even thinking about out of. We already did the out of how many possible combinations there are. There's 56, but we don't care. Now we're not thinking about probability yet. Right now we're just thinking about the numerator, and the numerator is based on how many ways there are to pick two songs that happen to be our 4 favorite. And so it seems like there's 8 times 7 or 56 possible combinations of songs. Then there are 4 times 3 or 12 possible combinations of our 4 favorites.
So 12 over 56 would be our answer. Now, that's one way of looking at this. That's with P 8,2 on the bottom and P 4,2 on top. But it could just as easily be, we could say C order doesn't matter in this case, and so really we should have C 4,2 up top and C 8,2 on the bottom. Well, and that would make no difference at all. We'd have 28 on the bottom and 6 on top. And so it's the same, and of course it's the same fraction. It should be reduced to 3 over 14, really. What should happen. And that's our answer. All right, I've had some technical difficulties, and so I'm going to have to stop the video early without really finishing this section, so I'll have to do the rest of the video on a separate video, which won't be ready until tomorrow, Thursday, May 12th in the afternoon. Thanks for watching. See you later.